Today, I'm going to work with you on a new concept, and that is the concept of what we call electric field. We spent the whole lecture on electric fields. If I have a charge, I just choose Q, capital Q and a plus at a particular location, and at another location I have another charge, little q. I think of that as my test charge. And there is a separation between the two, which is r. The unit vector from capital Q to little q is this vector. And so now I know that the two charges, if they were positive, let's suppose that little q is positive, they would repel each other. Little q is negative, they would attract each other. And let this force be F. And last time we introduced Coulomb's law. That force equals little q times capital Q times Coulomb's constant divided by r squared in the direction of r roof. The two have the same sign, it's in this direction. If they have opposite sign, it's in the other direction. And now I introduce the idea of electric field, for which we write the symbol capital E. And capital E, at that location P, where I have my test charge little q, at that location P, is simply the force that a test charge experienced divided by that test charge. So I eliminate the test charge. So I get something that looks quite similar, but it doesn't have the little q in it anymore. And it is also a vector. And by convention, we choose the force such that if this is a positive test charge, then we say the E field is away from Q if Q is positive. If Q is negative, the force is in the other direction, and therefore E is in the other direction. So we adopt the convention that the E field is always in the direction that the force is on a positive test charge. What you have gained now is that you have taken out the little q. In other words, the force here depends on little q. The electric field does not. So the electric field is a representation for what happens around the charge plus q. This could be a very complicated charge configuration, and electric field tells you something about that charge configuration. The unit for electric field, you can see, is newtons divided by Coulomb in SI units. And normally we won't even indicate the unit. We just leave that as it is.